Good morning to our viewers. I am Bea Carpio, Group 1's aspiring chemist. In this video, we are going to prove the law of conservation of mass discovered by Antoine Lavoisier in 1789 using an experiment. But first, my friend Diana will give a short explanation of what it means.
Okay, so according to our friend Antoine Lavoisier, the law of conservation of mass simply states that mass is neither created nor destroyed in a chemical reaction. If we account for all reactants and products in a chemical reaction, the total mass will be the same at any point in time in any closed system.
Now that everyone is knowledgeable of the law, let us now proceed to the experiment.
For this experiment, we are going to make use of baking soda, vinegar, a weighing scale, and a Ziploc bag, measuring cups.
First, we will establish the amount of baking soda and vinegar so we will have a reference point. In this case, 0.01 kg of baking soda and 0.05 liter of vinegar. Then, for added credibility, we will perform 3 trials, with the trials having 0.0005 of interval to each other.
That's right! However, we will use the units grams and milliliters instead of kilograms and liters, so let us convert them accordingly.
Let us first convert all the kilograms to grams. Trial 1 uses 0.01 kilograms, Trial 2 uses 0.0105 kilograms, and Trial 3 uses 0.011 kilograms. Let us now multiply them to the conversion factor, which is 1000 grams over 1 kilogram. Gram is put at the top since it is the unit we are trying to get. Then, we cancel the kilogram unit and multiply the quantities. So, after this, we got 10 grams for Trial 1, 10.5 grams for Trial 2, and 11 grams for Trial 3.
I have also done the same with liters to milliliters. Trial 1 with 0.05 liters, Trial 2 with 0.0505 liters, and Trial 3 with 0.051 liters. Multiply with the conversion factor 1000 milliliters over 1 liter. Cancel the units and multiply the quantities. So after this, we got 50 milliliters for Trial 1, 50.5 milliliters for Trial 2, and 51 milliliters for Trial 3. For anything else, let us prepare all our needed pieces of equipment and ingredients. For this experiment, we will make use of 3 varying measurements for each substance. For the first trial, explained by Miss Bea Carpio,
We will be using 10 grams of baking soda, 50 ml of vinegar, and 1 medium-sized Ziploc bag. First off, we must prepare our baking soda packet. Put 10 grams of baking soda in a paper towel and fold it in, and create a small sealed pouch. Next, pour 50 ml of vinegar in the Ziploc bag. Together with the baking soda packet, we must measure the mass of the bag before the substances meet. So the total measurement beforehand, including everything, is 60 grams. Properly secure the bag. Make sure that there's little to no air escaping. Lastly, let us observe the reaction and measure the mass and weight of the substances. After the reaction, the mass is still 60 grams.
Let us now proceed to the second trial.
We will be using 50.5 ml of vinegar, 10.5 grams of baking soda, and a medium-sized Ziploc bag. Similar to Miss Bea's trial, we must create a packet containing 10.5 grams of baking soda. Pour 50.5 ml of vinegar in the bag. The total measurement before the reaction is 61 grams. Put the packet inside the Ziploc bag and seal properly. Let us observe and measure the mass after its reaction. As the scale indicated, the mass after the reaction was still 61 grams.
For the last trial, performed by Miss Leana Mangolabnan,
we will be using 51 ml of vinegar, 11 grams of baking soda, and a Ziploc bag. Similar to the first 2 trials, I will follow the same procedures and will measure the mass before and after the reaction. The mass before the reaction is 62 grams or 0.062 kilograms. Let us now put them together to react. Measuring after the reaction, you can see that the mass is still 62 grams or 0.062 kilograms.
So, how did this happen?
The combination of baking soda and vinegar exhibits a chemical reaction that creates carbon dioxide gas. Knowing that carbon dioxide was created, it has mass, the total mass should have increased.
That's right, Liana. Carbon dioxide was produced. However, the mass was merely rearranged. Let's take a quick look at the balanced equation.
As you can see here, the amount of atoms in both equations are the same. Hence, it has the same mass.
With that out of the way, let us now compute for the accuracy and precision of our experiment.
We will be using this equation for the percent error of accuracy. Subtract the first trial from the true value to get the first absolute error. Repeat for trials 2 and 3. Combine the differences to get the TAE. Divide the TAE from the number of trials conducted to identify the average absolute error.
Divide the average absolute error from the true value and multiply it by 100 to get the percent error of its accuracy. The lower the percent error, the more accurate the measurement is relative to the true value.
For the equation of percent deviation,
Combine the results from the 3 trials and divide it to the number of trials to get the average reading. Subtract the results from trial 1 to the average reading. Repeat for all the 3 trials. Combine all the differences to get the total absolute deviation. For the computation of the average absolute deviation, divide TAD to the number of trials.
Divide AAD to the average reading and multiply it by 100 to get the percent deviation. The lower the percent deviation, the more precise the measurement is relative to the true value.
So here, we got 3.39% as a percent error and 1.14 as a percent deviation.
overall, we can conclude that the law of conservation of mass is indeed true, proven by the experiment that we conducted. Our observations show that the mass of the substances did not change at all. This supports our hypothesis that the mass of the two reactants before and after a reaction will remain the same at any point in time, given that it is in a closed system, which proves it to be true.
As for the percent error and deviation, it means that our measurements are not extremely accurate and precise due to the fact that we have no proper equipment. In ideal situation, we should have used a lab scale which can measure more accurately, but due to the current situations, this was all we could do.
However, this does not take us away from what we have proved. We have finally answered our question. Is mass conserved after chemical reaction? The answer is yes. Thank you for watching our presentation. This is Miss Bea Carpio.
And this is Miss Liana Mahulugnan. Until next time,
Goodbye!